Alright, physics, we're back. It's after the quiz, which mostly went fine. Uh, Again, if you have more questions in the quiz, just come find me. But I think I went over most of it during class. Um, a blank slate over here, even though what we're talking about isn't going to be completely blank slate. I'm not going totally tabula rasa here. I'm actually going to build off of what we have been talking about here with stuff falling and what we have been talking about here with stuff moving kind of forwards and backwards. I'm going to take all that, I'm going to kind of combine it because in real life, things don't only fall straight down, things don't only go across, usually they do some combination of the two. When that happens, we generally call it a special case of freefall. We generally call it projectile motion, which I can give a loose definition, right? When an object oh gosh, spelling. What even is spelling? In free fall also has horizontal motion. Right, so it's falling down. The only thing acting on it is the acceleration to gravity, but it also happens to be moving side to side. So generally, like a baseball is a projectile, right? Something that you throw across the room. A pencil could become a projectile. People become projectiles when they jump, right? If you're a long jumper, or I guess triple jump, any kind of jump, right? Any kind of jumping that you're doing that's not just a straight vertical jump, you're a projectile. You're a human projectile, all right? Just like, so all the rules for free fall apply, which means that the acceleration is the acceleration to gravity. It's 9.8 meters per second squared, pointing down. But there's like additional stuff that you know that you will automatically be like, I can definitely tell this because this object is a projectile, right? So normal free fall rules, and also x direction velocity is constant, or x direction acceleration is 0, right? That's definite. I absolutely know that because we ignore air resistance. We mostly leave it for engineers. And a projectile is defined as an object in free fall with horizontal motion that also doesn't have an engine, right? An airplane is not a projectile because it has engines that are telling it go forward, right? A bird is not a projectile. It has wings that tell it stay up, also move forward, right? But quite possibly the most important thing, x direction and y direction motion and information. That's not how you spell information. Have no influence on each other. Which is why the acceleration is all down and nothing over. Right? It's really important. And I believe, I'm pretty sure I said this before. I said it over, oh goodness. I said it over here. The components do not influence each other. Horizontal and vertical motion are independent. Right? So this is why this is an extension of freefall, not like its own thing. It's not strictly its own thing. Now, you'll notice that here we're looking at something going only straight up, only straight down, only straight up and down. We're now going to start worrying about objects that are doing both. They're moving up and down, or they're falling down and they're moving horizontally. A very, very typical question like this is, and I'll kind of, hello. There we go. Let me finish my building. Alright, so we are on top of a 20-meter tall building, and we are kicking this ball at 5 meters per second. And the very common question, a student kicks a ball horizontally at 5 meters per second from a roof 20 meters above the ground. How far from the base of the building does the ball hit the ground? Right? So, just as before, we're going to pull information out from the paragraph, from the words, but we have to be very careful to separate the information into information in the x direction and information in the y direction. And we need very much to keep those things separate. All right? There are a handful of things that we just know. So I know that the acceleration here is 9.81 meters per second squared. Down. I know the acceleration. Let me go to the color. Hello? There we go. Sorry, technical difficulties. I know the acceleration here is 0. Right? 5 meters per second horizontal. Horizontal is this way. That's x direction. So I know that the initial velocity is 5 meters per second. Now, what is the initial velocity in the y direction? If everything is horizontal to start, then nothing is vertical. Because of the word horizontally. Because of that word. That tells me that in the y direction, I have not kicked the ball up, nor have I kicked the ball downwards. I've kicked it straight across. And because of that, I know that the initial velocity in the y direction is 0. I know the change in distance is 20 meters here. I have no idea what the change in distance is here. That's kind of what I'm looking for. And there's one more piece of information which I will do in a different color. I don't know time. However, you should notice that I've made the y information green, I made the x information blue, I made the time a different color because the amount of time it takes for this object to drop is going to be the same amount of time that it takes to move horizontally. They happen at the same time, which is why it looks like it follows an arc. So if I know how long it takes to drop, then I also know how long it takes to move horizontally. If I can find this time, then I can use it here. All right? So, if this was just a ball that was dropped from a 20 meter high rooftop, I would know how to solve that. I would know. I'm gonna move down a little bit again. Can we see? Can we see? Yep, we can see that. Okay. I would know that the change in distance is equal to initial velocity times time plus 1/2 acceleration times time squared. So I know that 20 meters is, this all goes to 0. So 0 plus 1/2 times 9.81 meters per second squared times time squared. This is about 40. It's about 10, so time is give or take 2 seconds. I'm skipping a little bit of math here, but if you do the math, you should get, give or take, 2 seconds. Or it's going to be like 2.01 or something like that, but it's almost exactly 2 seconds. That's how long it takes. So I know that my time is actually 2 seconds. So now I can use my x information to find the change in distance is velocity times time plus 1/2 at squared. And this time, the second half is 0. So my change in distance is 5 meters per second times 2 seconds, which is 10 meters. That's how far away from the base of the building the ball hits the ground. It hits 10 meters away. That's not that far, but they also didn't kick it that hard. Right, that's all that happened. Right. When you have questions like this, the big deal is no longer just pulling information out from the words, pulling information out from the paragraph. It's now recognizing which of that information is X and which of that information is Y. All right? I'm going to put up 2 questions very similar to this, but I just want you to be able to have that practice of identifying information, putting it into the correct context. Is it X information? Is it Y information? And then also remembering that acceleration in the X direction will be 0, acceleration in the Y direction will be 9.81 meters per second squared, and that the time is the only thing that's allowed to go back and forth. All right, look for those questions. They'll go up on my CBA. Look for the assignment. Until B-Day, I will see you. Take care, physics.